Hi, Chris here for 10k Tech and welcome to the channel. And today it's the Arduino series about variables. So let's get started now. Launch the program, looking up for Arduino IDE, either going to the start menu or using any other shortcut that you have. Once this opens, it will go to the last sketch you had. For us, it was the blink sketch, if you do remember. If you do not know, I will advise you to look down in the description below. I will put a link for you to follow and understand what we are speaking about. There is nothing wrong with this sketch, but it's very primitive. It's usually the first one we do. And now we are going to improve our knowledge and dip a little bit deeper with the variables. So let's get started in the how we do that, what is variables, how we apply them, and so on and so forth. We take our previous project, that's why it's still on the screen, as a base. We will be building onto that by implementing a Morse code. But not to worry, I will guide you through and help you with the code. We will use the SOS message, and while doing this, we will do some errors to show you what not to do or to explain to you why you should not use or write particular things in that context. So the SOS stands for Save Our Ship or our souls, depending on where you are. And this was done before the telecommunications era. If a ship was sinking, it was sending a Morse code where every letter is represented by a series of dots and dashes, and it uses a very low bandwidth to communicate through the airwaves. This is how it sounds like, but you can also do the same with light, and that's what we will do now. First things first, we need to rename and to save the file. Let's say we will save it as a Morse code. If you want to know more about this code, just check out the video as I say. The link will be down below once again. Okay, so we rename this Morse code. We go to File, we save as, and actually, so once we wrote this, we Control and copy. So I did a right click and copy, but you can press Control and copy on your keyboard. Then you go to File, Save As, Control V, or you can press right click here and paste, right? And then it will save in the library. Let me bring it here, like this you can see, sorry. Alright, Save As, and there it is. Okay, so this is saved as Morse code. You see it has changed. Basically what we will do is we will turn on the LED connected to pin 13 and the onboard LED will turn on, of course. Now we will change this because it's not for 2 seconds. What we want is to blink 3 times for 1 second. Okay, blinking 3 times for 1 second. Then turn the LED off for 2 seconds. Then we copy all this because we will use that. Okay, so Control copy, Control V, there is an extra space there. Okay, so then we blink 3 times the LED for, let's say, 3 seconds. And then turn off the LED for 2 seconds again. Okay, we will try that first and see how it goes. So basically this will do ... and those will do ... Okay. Alright, now we go to the digital write, which is here. Alright, so turn on the LEDs, the delays, yes, and this we have to repeat it. So I will use Control and copy because we will have a lot of that to do. But the delay here, I do things, is too long. Okay, 2 seconds in between, we want ... So I do believe we have to put it to maybe even 50, not even 500, 50 milliseconds. Dit, off, dit. Which means here also we have to change it to 50. Okay, and now we can just select the whole thing here, control and copy, okay, there, and control and paste, okay, and I show you here we do, and we just paste, it works as well, okay. So we have dot dot dot, all right, with all the delays. But this here looks confusing, so what we can do is, after this one here, we can simply one dot, and it should be this one, 2 dots, 3 dots. Now we know about that. So now for the dashes, basically the easiest will be to copy the whole thing like so, okay, except the void loop, we don't want that. So control copy, we leave a space, I leave 2 to make sure we understand, control V, okay, so here we are 1 2 3, and we can clearly see it's different, a little bit more space. And what do we want to do? We want to turn on the LED. Oh, you see what I did? It's I copy without changing. So all here is all false. You can see here the delay is not 2 seconds, it's 50 milliseconds. So I have to change all of them. How can I do that faster? I'll show you right now. I press Ctrl and F, and this is what I find. And what do I want to change? I replace, I go to the replace here, I Ctrl and V because I already copy, and I put 50 and milliseconds and replace all. Okay, I can close and check, they are all at 50 milliseconds. This is how you can, if you have made a mistake and it repeats so many times, do. So basically I repeat, you press Ctrl and F to find, but it's best to copy what you want to find first, like this it will appear here first, and you can just paste it here to change whatever you want to change. Alright? That was a little tips. However, you can say, Chris, so I can use this to change those because we want them, you know, for the dash, dash, dash longer. I want them, let's say, at 500 milliseconds. But I cannot, because if I change all, I will change this one. I mean, there is a way to do, but since I have only this, I will change them manually, okay, for the time being. This is done. What do we need to do now? It's press 2 times. I will copy this like this, I don't have to change again the 50 milliseconds. You remember the one I have copied? I paste it here like so, and we have our sketch. The only things I have to do now is verify the code. There it is, there is no problem. So far so good. And then we will have to plug the Arduino and upload the code to the Arduino. So let's put this on the side and load the Arduino now. It went smoothly, but we have a problem now. Look at that, it doesn't really look like what we are expecting, isn't it? Basically what's happening is too fast, as well as all the dots are basically next to each other in the sequence. The first one is next to the last one when it loops over. So we need to increase the delay in between them. Let's try that and see what it does. Here, from 50 to 500 in between both, and see what it does. Okay, and the last one, of course, have to increase also because it's the biggest one. Now that I change, I just have to upload it to the Arduino, like so. Yes, it is better, but still, no, I think we can improve on this. As you can see here, let's do that better. Okay, one way to improve it is to add even more delay. So we leave a space, put a delay, and the delay this time I will put it of let's say 1 second, like I put in the description actually. Because until now we didn't do it and nobody told me anything. Anyway, so I close here and I will upload, but there will be a mistake and I know why, and I hope guys you follow the lesson before because you will know why. So let's upload that, and oh, you see, he expects a semicolon before the exit token, which is this one here. All right, so let's put it in and upload that right away. As expected, upload successful, and now you can see clearly there is a separation between, but still there is something missing. I'm not happy with the short one. They are too short, all right, too near to each other's. So is there a way to change it? A better way than to type everything, every single one? And yes, it is. And this is actually using variables with the Arduinos. Let's do that now. I'm sure you see the problem by changing all the dots with the longer timing to make them more readable. And let's say your boss wants you to change. He doesn't want pin 13. It's a bad number. Here in Asia, they like number 8. Let's say pin 8. All right. You see how many we have to change? You see the problem now? This is actually the concept of variables. You never want to use constants unless it's the short sketch, like blink, for example. Otherwise, variables is your ally. And where do we set up those variables, you will ask? It's very simple. We set them up before the void setup, just after the comment here. So we can make some space here and we can start to write here. There are actually many types of variables, but for the sake of the Arduino, mainly there will be two types for the numbers. You have the full number, like 1, 2, 3, 4, 5, 6, 7, so on and so forth. You can have also in the same one, -1, -2. You get my drift. Those ones are called, I'm sure you heard this name before, integers. That's the name of those. And the other type, it's all the other numbers. Means as soon as you introduce a decimal or the number is not a full one. 0.1, for example, 314 pi, not the Raspberry Pi, but pi like 314. You get my drift. And those are called floating numbers, are numbers with a decimal or composite numbers, and they too will be located in the sketch before the void setup. First, we need to establish what do we need to change. Do we need an integer or a float? So we will need an integer, and it is spelled as int. As you can see here, it's the wrong format. Now it changes color in blue, means it's the correct format. int means integers, and we will put the LED, all right, because we want to change the pin, but we don't want to change all the 13 to whatever pin we want. And let's say our boss wants to change again, then that's the way. So as you can see here, I'm writing a few things, and this is how you should put the name. So you can put green LED, blinking LED, whatever you want. We will put LED1, and we will put the pin. Okay, so like this we know this is for the LED1 pin. All right, then this will be equal to wherever the LED is connected. Here we put it, to remember, pin 8. The next one, what should it be? An integer or a float? We will put it as an integer, but I'm going to show you for float, right? Although we are not going to use it, you still have to know how to write it, and this is how. So pi, it's equal at 314, for example. And of course, do not forget the semicolon. That's very important. What should we set next? As we already did the LED previously, previous to the float, of course. We have to do the ... okay, to change all the delay. So what will it be? Will it be a float or will it be an integer? It's simple. The delay here, as you can see, it's a full number, so it will be an integer. And we will call it dot to be original. Anyway, dot, it was too short, so we will put it to 100 milliseconds. The next one, we will do the integer for the dash, right? So the dash one, we were at 1000 milliseconds. Is that correct? Or 500? 500 milliseconds. Then if you look in our description, I mean 3 seconds on and 2 seconds off, we weren't really doing this, so this will have to be updated, alright? For the time being, we will try this and see how it goes. How do we change everything in the sketch to make it easier for us and make sure we avoid any mistakes. If you remember previously, we use the Control F to find, but first we need to copy the line that we want to change. Once the selection is made, just copy and then Control F, like so. The number that we copy will be automatically added. We just have to put what we want to change to. And we press replace all. So you can see everything is replaced. I mean, all the number 13 are replaced by the number 8, as you can see here. Wait a minute, didn't we just set up the variables up in the sketch? Yes, you are correct, we did, and it's much easier to replace the number 13 not by the number 8, but by what we declare instead. Now, I'm going to show you how to correct that. We are going to select the number 8 with a comma. It will be easier. Control copy. Now we control find. Okay, you can see the 8, and we will copy the LED pin. All right, all the LED pin like so, and paste it in our Control F there. All right. So Control V now. The LED pin here, because we copy, we have to change, so we put back the 8 and comma. Replace all. As you can see here, it's done, but it's always best to double check. The next one on our list, it's the dot. So how are we going to change this? Because if we select only the number 50, it will also change the 500, which will become .0. After, you remember, it's the delay for the dash. We put it at 500. So we just select with the parentheses. Control copy, Control F. As you can see, it is there. Then we just have to put in the parentheses the dot and then replace all. That's what we are going to do now. And what's happening? The delay in the dash also changed to dot. It's simple. It's because it was the same number. So now you can see that it's always best to check and double check. So we are going to change that, but later on. Only because we have the opportunity to speed up the things just by adding a 0 in the 100 and removing the O and T and putting ASH for dash, like so. Then replace all, double check, and we notice just by doing so we replaced all the dashes and dots. Now we can double check our sketch and apply the change. You remember it was to the delay, either to dash or to dots, like this one here, because they had to be based on timing and not dot or dashes. The only thing that we have to do now is to create what? Is it a float, an integer? Yes, you guessed it right again. Wow, you're on the roll, guys. We will create an integer with a special timing. What we will call it, this will be entirely up to you. But for our case, we will call it long wait. For example, because this is what we want. We want to replace the delay here by a long wait. So I put an integer, int, all in small. You can see it turns blue. Long majuscule, first letter only. The first letter of the next word will be with a majuscule as well. So long wait, and we will equal this to 1000 milliseconds or 1 second. All right, and we just have to copy this with Control copy, put it in between the parentheses, Control V, and there it is. And we have to repeat this everywhere we want to apply these changes. Once this is done, we just have to verify the sketch by going on top left corner and select the verify button. There is a mistake. You can see here, I did them on purpose to try to explain to you how the Arduino IDE works. If we zoom in the error message pan, like so, we can see that the Arduino IDE will tell us what's wrong. And now looking at the sketch, we can see that the error is highlighted. I mean, the line where the error is highlighted. The only thing that we have to do now is to apply what was missing as per the error notified downstairs. Then we just have to select the verify button again, but here I have to guide you through because it's not so obvious. You can see here, you don't know what's missing. But if we look above, highlighted section, then to me it's obvious. But can you find what's missing or what's extra? Or did we spell something wrong? Do you think it's the pin mode? No, it's not. It's the correct color. Is it the LED pin? We copy and paste. It cannot be. Is it the output? No, it was working before. The only thing missing is the comma. And that's about it, really. And all over the sketch it will be like so, because when we copy, we forgot to put the comma, and when we paste, the comma is missing everywhere. So we simply have to copy and paste again, but this time with a comma. So let's do that now. It is always advisable to go back to the top one, like this you're sure that don't miss anyone. You just select the items, Control and copy, Control and F, and don't forget to put the comma, of course, and paste all. Everything has changed. Now it is just a matter to verify again once more and see that we have to remove the extra comma before the equal sign here. This is another mistake we need to look for when we paste using the Control F command, because it changes all the instance of what we are changing when you do replace all. And our sketch also will not work if we do not remove this comma here, or we will have to add an extra comma in each and every instances in our sketch down below. Okay, so we can check everything like so and see if we have more errors, and so on and so forth until the errors are all resolved. Then it is time to upload our improved sketch to the Arduino and see the results. That's weird, nothing happened. But if you recall, we did change the pin. It's not in pin 13. That's why the sketch have nothing. You can see there is no light whatsoever. And this is simply because we changed the pin number. And the sketch as well, of course. Let us change the pin from 13 to 8, like so. And as soon as I plug it in, you can see our sketch resume, dot dot dot, dash, 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 dot dot dot, and then the long way. And now at this time, if we want to change, we just have to change the integer or the float for the whole sketch, and everything will be updated. Let's say that I find the dashes too long or the dots too short. I can make them longer just by changing one number, and that's what we will do now. Upload it again and see the result. Your boss can even change the pin number, because you remember I did say it was our boss. Anyway, so you can change any pin number at your whim. And as long as you follow the same on the Arduino than what's in the sketch, then your program will work just fine. Now that we changed the sketch to whatever we want, we can simply upload it again to the Arduino, change the pin to pin 1 as we did in the sketch, and there it is. Now you know everything that I know, almost, at least for this week. I hope that this helps you very much. And before I leave, try to imagine if there was 3 LEDs, like for example our next sketch, maybe we are going to do a traffic light. So we have 3 LEDs who have to blink in a certain way. Try to imagine how you can do it, and next week that's what we will do. Now you can do your YouTube things, like, subscribe, or even press the bell button if you want to be notified next time I post a new video. However, if you do not like this, as usual, simply leave a comment down below to tell me why you do not like this video. Stay safe guys, bye now!